So this problem comes from section 2.1. It is number 1. And this is to set up the integral that gives the area of the region bounded by f of x equals x squared plus 4 and the x-axis. So the first thing I want to do is put this function into my graph calculator so that I can take a look at what it looks like. And so here is the function. Here's my function f of x. And I am looking at the region that's bounded by the x-axis. So this is the x-axis, or you could say, you could put in here y equals 0. The x-axis is that horizontal line. So I'm looking for this region here. And so I'm looking for the area of this region here. So I'm going to draw that on my paper here, just a rough sketch of that graph. It looks something like this. Oops. Something like that. So we are looking at this region here, finding the area here. And we need to find A and B. So in order to find A and B, we need to find the points right here. And so we can do that either with the graphing calculator and finding those intersection points, or what we can also do is if we let the output equal 0 for the function f of x, we can find that. And so if we plug in 0 here, we can do some factoring, and we will get x equals 0, x plus 4 equals 0. So that means x equals 0 or x equals negative 4. And so the points here, this would be negative 4, and this would be 0. So that is my A and B. And so now I need to find the integrand. Well, when I'm finding the area, I need to use, if we look in the book, I'm looking at theorem 2.1, and it's finding the area between two curves. The area is equal to the integral from A to B of f of x minus g of x dx. And so it tells you that f of x and g of x are continuous functions such that f of x is greater than g of x over the interval from A to B. And so in this case, the x-axis, which runs here, is the line y equals 0. And so this would be my top function, and this right here would be my bottom function, and this is below. So my f of x, putting it in here, f of x minus g of x, my f of x would be 0. And g of x would be x squared plus 4x. And so now I'm doing some algebra here. When I take a 0 minus, I have to distribute this negative out. And so I'll get negative x squared minus 4x dx. And so this is my integrand, negative x squared minus 4x. And then we're going to give the antiderivative, and it tells us to omit plus c because this is a definite integral from negative 4 to 0. So taking the antiderivative here, we would end up with negative x cubed over 3 minus 4x squared over 2. And then when I simplify this, the 4 over 2 will divide out and simplify to 2. And so negative x cubed over 3, or you could say negative 1/3 x cubed minus 2x squared is my antiderivative, and that is going to be from -4 to 0. And so now to evaluate that, I'm going to say plug in 0, and then plug in -4. And then I'm going to put this in my calculator and see what I get. And I can also, this asks for the exact area, so I don't want to plug it in my calculator, but I can plug it into my calculator, check. Here is this side's going to be 0, and this will be minus, and then let's see, we'll have -4 cubed, which is, so the opposite of -4 cubed, that would be a positive 64 over 3. So this would be -64 over 3, and then the opposite of that is a positive 64, and then minus 2 times 16, so that would be 32. And so I've got 0 minus, and then finding my common denominator here, which is 3, I would have 64 thirds minus 96 thirds. 64 minus 96 gives me a -32 over 3. And remember, this is 0 minus this. And so I'm going to get a positive 32 over 3. And if you had put this into your calculator, you would have gotten positive 10.667, which is the same as this. So this is, but I wanted the exact answer. I don't want a decimal, so we need to do it by hand there to find that. So 32 over 3 is the exact area.